Good morning, class. So today we're going to start talking about motion. So what that means is we're going to talk about the difference between distance and displacement. But before I get started on that, a couple housekeeping things. Make sure you put together a folder or a file in your desktop or on your drive or a physical folder where you're printing things out and starting to place them in that folder. That'll help you out in the long run. So make sure that you're organizing your supplies, because all of these things that we talk about week after week are going to come back up again. And one of those things is sig figs. So make sure you review sig figs and scientific notation. So you'll see those again, and you'll need to know how to do conversions. So don't forget that information once we've learned it. It's kind of like math in that way. It just builds on itself day after day. So week after week. So right now I want you to get out a piece of paper. And on that piece of paper I want you to create a sketch. So a sketch of a car, it can look however you want it to look. It doesn't have to be an amazing sketch. But just a quick sketch of a car with wheels and a boy inside of that car tossing a ball up in the air. Now what I want you to do is make a model of what's going on in this image. So if the car is driving past you and the kid is tossing a ball up and down in the air, what in this image is moving? Now I'm not talking about speed, I'm talking about what is in motion. What is going to be traveling and how is it going to be moving? Let me get out my paint program here. So if I were to draw what is moving on this image, I might say like the tires are rotating. Right? So they may move around 1 or 2 or 3 or however many revolutions in this image. What else is the car doing? Well, the car might be moving forward. And what else is happening? Well, you have a ball being tossed up and down the air. So what I want you to do is just go through this image and think about everything that's moving in your image and draw arrows. Draw a little diagram showing everything that might be moving in the image. Now I want you to think about different perspectives. What would happen if I were looking at the top of the car and the car actually swerved? How many different forms of motion is happening in that image then? So if the car begins to swerve, what would happen? What types of things would be moving in that image? Then, if we were to travel further out, so you don't have to draw this on your paper, I just want you to visualize it. If we started traveling further out, further and further away, until we came to a place where we were in outer space looking at this car, what is moving in that image? Well, you might say the Earth is rotating, the car is moving, the boy is throwing a ball. So you can see how different forms of motion begin to add up more and more and more as we go along. Now let's imagine for a second the boy is inside the car and he can't see out of the windows. All he sees is his ball. He might believe that the only thing moving is his ball up and down, just based on his perspective. So your perspective and how you're measuring that ball's motion matters. So the person from the street might see the ball as moving up and down, but also moving forward. So when you guys are studying motion and when you're just studying distance and displacement, you want to take into account the perspective, and you want to think about the perspective that's being studied. However, for this week, we're breaking it down as simple as possible, and we're doing motion in one dimension. When you are studying physics, you want to break down a complicated system into individual events, and then take those events and study them apart from the whole system. So what I mean by system is the whole thing that's going on here. The car's moving, the ball's being thrown up and down, the Earth is rotating, our solar system's rotating around our galaxy, so there's a lot of motion happening, but we want to isolate certain events and then just study those. Well, in this week, we are only focused on a 1D environment. So we would focus just on the ball moving up and down, because things get a lot more complicated when you try to focus on everything at once. So when you have a problem in life or in general or in physics or in math, you want to break that problem down into the simplest form and just solve that simplest form of the problem instead of trying to tackle the whole thing. Alright guys, I hope you enjoyed this video. Make sure that you take that image that you drew and I want you to post it on Google Classroom for me on slide 4. So you're going to take a picture of that image and post it on slide 4 for me using this insert image icon, and then you can use your camera on your Chromebook to take a picture of it, or if you take a picture with your phone, you can upload it from your computer. And that's it. I hope you guys have a great day. I will see you back in the next Zoom meeting. Bye.